Okay. Good morning, everyone.
Good morning, sir.
Good
Good
morning,
morning,
sir.
sir.
Okay. Last time I'm given an assignment about a pipa and loopback address. It was very small, right? I hope so. So I know that Prathamesh will present it later. The rest can. Okay. Kunal. Yeah. The rest can start presenting, starting from Digvijay, Shrecha, Kuber, Momita, and Kunal. I think Kuber must not be there. Kuber was not there. Kuber, your Doxys assignment is also not there. Huh? Please mail me your Doxys assignment.
Sir, it was in group. Shrecha sent you in mail.
Okay. Shrecha, just a minute. Okay. Who was not there? Okay. Right. So, yeah. Digvijay, you can start. Then Shrecha, then Kuber, then Momita, and Kunal. As you see on the screen, we'll go one by one. It shouldn't take more than 5 minutes for each. I mean, it's not much on
Okay,
those
sir.
topics. Yeah. Yeah. So go ahead.
Yes. Sir, is screen visible?
Not yet. Yes, now it is. Both of you are speaking, Kunal and Digvijay. I'm not able to figure out who is this.
Sir, I don't start yet.
Okay. Kunal, could you please mute? Yeah. Go ahead,
Sir,
Digvijay.
may I?
Yeah, go ahead.
Good morning, sir.
Good
Uh,
morning.
Here is our assignment number second, understanding the API PA and the loopback addresses. Firstly, what is the full form of this? That is automatic private IP addressing. This is my first slide, which are included characteristics and their differences, which will be in present in the next slide. This is the structural representation of how it's actually work. Then what is it? First point, the automatic private IP addressing. It generally allows the devices on a local network to communicate with each other without a DHCP server. And generally, it is self-assigned addresses. Means when a device fails to obtain an IP addresses from the DHCP servers, it automatically assigns itself a temporary addresses within the range of 169.2.4.0.0 up to 16 ranges. Then third one is temporary and private. Generally, these addresses are only valid within the local networks and are not routed on the internets. And the fourth one is limited communications. The devices with these addresses can only communicate with the other devices with the same local networks, not it by the external networks. Then how it generally works? First, DHCP request, it send DHCP request to the device. Then request it obtain generally the IP addresses. If the responses are not, assume the temporary files are created, then the device select a random IP address within the range which is given to the system, and then the device can communicate with the other device on the same local network but with the external networks. Then these are the characteristics of these addresses. Means this is range, automatic assignments, private network use. The range generally falls within the uh, this only 1.6 169.2.4.0.0 to 16 ranges. Then the automatic assignments, device automatically assign themselves the addresses in which the absence of DHCP server. Then the private network use. These addresses are only valid within the local networks and not routable on the internet. Then what is loopback address? Uh, Internal communication and testing applications. Two parts included in this. The loopback addresses enables the communication with the single devices, efficiently allows a device to talk to itself, and the testing network applications. Generally, the loopback address is used to test the network applications and protocols, ensuring that the functions correctly without relying on the external networks. The next one is the unique addresses. The loopback address is reserved for the internal communication and cannot be used for the communication with other devices on the networks. Then the address usage. First one is network troubleshooting. Thus, in it, the addresses help diagnose the network issues by testing the network interfaces and the applications. Next one is the application testing. The developers use loopback addresses to test the network dependent applications, ensuring that the functions correctly before deploying them on network. And the third one is the security considerations. Then the loopback addresses play a crucial role in the network security by providing a way to the control access to the internal resource and prevent unauthorized accesses. Then this is difference between the API and loopback. The purpose of first one is the temporary communication within a local network, and the loopback means internal communication within a single devices. This address range, this is the major difference in both of these is their ranges. And in API automatically it assigns by the devices, but in the loopback it reserved and it are predefined assignments. Then communications. Sir, is screen visible?
Yes, it is.
Okay. Then these are some issues. First one is network cable issue, in which it ensures proper connection between the devices and the network, checking for the loose or damaged cables. Then the second one is DHCP server issue. It verifies that a DHCP server is available and properly configured to assign IP addresses to the devices on the network. The third one issue is the network configuration. It generally checks the network settings to the devices, ensuring that the correct IP address and the subnet mask and the default gateway are configured or not. Then the last one is firewall. It generally checks, ensures, and devices firewalls are not blocking necessary network traffic or application is present or not. Then the best practices for the both are first one is DHCP server configuration, network monitoring, security practices, regular maintenance. First one, DHCP server configuration. It generally deploy and properly configure a DHCP server to ensure devices on the network receive valid IP addresses. Then the next one is network monitoring. It implement the network monitoring tools to detect the troubleshoot network issues related to both of these addresses. Then third one is security practices. It implement strong security measures to prevent unauthorized access to the internal networks and the devices using loopback addresses. The fourth one is regular maintenance. Performance regular network maintenance to ensure devices are properly configured and the network services are functionally optimally or not. So thank you, sir.
Thank you, Digvijay. So this was a good PPT. Okay, nice. Just okay, bring back the PPT. Okay, never mind. It's fine. So
Okay.
couple of few points. Key when you are starting introducing, you don't need to talk about the slide, like slide one and this and that. Just start. Okay. First, second, there is a lot of what you say, theory kind of thing. Okay. So try to introduce more of the images, a figure which you can explain rather than the theory, and just reading out maybe and giving an example will help. Okay.
Okay, sir.
What this will do is presentations में तो help करेगा ही, but when you are explaining it to someone in an interview, you will directly automatically start with the examples. Okay, this makes
Okay,
a
sir.
difference. So like as more and more assignments we do, practice. Okay, make sure you incorporate these things.
Yes, sir, sure.
Okay, next, Kunal. Kunal, are you there? Okay, next, Prathamesh will do it later. Momita. Prathamesh, I understand that you will present it later, but make sure you send it on mail. Okay. Whoever after your presentation, guys, please send the PPT on mail.
Hello, sir. Is it visible?
Yeah. Yes.
Our topic is API IP address and loopback addressing. What is API address? That is automatic private IP addressing, which is noted as 169.254.0.0. API comprise automatic private IP addressing, a network functionality that enables computer to automatically assign themselves an IP address when they are usable to acquire one from the dynamic host configuration protocol server. API will be employed when a device that is intended to use DHCP for obtaining an IP address fail to connect with the DHCP server. In this case, it assigns itself an IP address range within API, usually between the limits of 169.254.0.1 to 169.254.255.254, having a subnet mask of 255.255.0.0. The total number of hosts in automatic private IP addressing is 65,536, and the usable hosts are 65,534. How does API work? If your devices are unable to obtain an IP address from DHCP server, automatic private IP addressing allows them to choose one from a certain range on their own. A device with API active will self-assign an IP address ranging from 169.254.0.1 to 169.254.255.254. if it cannot connect to the DHCP server for getting one. In this case, communication with the local network can still be done using this self-assigned IP address despite of non-existence of a DHCP server. In this way, APIPA makes sure that no disruption occur due to lack of assigning IP address among devices communication and operation, even in outlying situations where they fail to reach to a DHCP server are responsible for providing it. Then um, what does loopback address mean? A loopback address is a distinct reserved IP address range that starts from 127.0.0.0 and ends at 27 127.255.255.255. It The last address is broadcast address. The loopback address are built into the IP domain system, enabling device to transmit and receive the data packets. The loopback address is generally known as localhost. Uh, Advantages of loopback address: it is an efficient method to find a device on the network. And the loopback address is used as a source and destination address for testing network connectivity. It can also used for testing IP software. That's it, sir.
Thank you. Take it to the upper second slide. Yeah. This is a question for everyone. How did the number of usable hosts come to 65,534, or total number of hosts come to 65,536? It is correct, obviously, but how did we come at that number? How did we get that number?
Sir, I did the calculation on
Hmm.
IP calculator.
Okay. Without, I mean, what was the logic without the IP calculator? IP calculator directly gave you the number, right?
Yes, sir.
Yeah. Okay. So a question for everyone is, how did we get that number? How directly, I mean, show me the math. What was the logic behind getting this number? Remember the subnetting slash two
Yes,
raised
sir.
to things?
Yes, sir.
Yeah.
See, it's
This is a
actually
question for everyone. Actually, other than Momita, others answer. Last time, I think. Kunal, I had explained, you had asked the doubt, right? That you did not know how I'm getting the ones and zeros and the two raised to's.
Yes, sir.
Okay, okay. Tell me, Kunal, how do we do it here? Others also, if you attend, I mean, if you are paying attention, if you understood, shouldn't take you 2 minutes. I just need the logic. Just So address range also,
Sir.
so we are on the same page. It was 169.254.0.0/16, right? Momita, that's
Yes, sir.
correct, right?
Yes, sir.
169.254.0.0/16. So based on this, they came up with the number 65,536 total number of hosts, number of usable hosts minus 2. What was the logic? What were the steps that through which this number came?
So the host portion consists of 16 bits. So the number of
16
possible
bits.
addresses in a 16-bit host portion is 2:16. That is 65,536
Good,
IP addresses.
good. That's it. So /16, like I said, maximum is /32. Why? Because there are 8 bits and 4 octets. So that's 32. So 32 minus 16 would give me 2 raised to 16, and 2 raised to 16 will get you this number. I hope so others have got it. Okay. Thank you, Mamita. That would be all.
Thank you, sir.
Next, that the Mamita done, Digvijay, Kuber, I don't know. Then Kunal, Shrecha, and Ashay. Any one of you can start. Okay, Ashay was not there last lecture, but I expect, Ashay, if you are listening, I expect your assignment on mail by today or tomorrow, and you will represent it next week. For those who are not there, I
Sir,
think, yeah.
I have made a PPT. Just a second, my
Uh-huh.
laptop is. Sir, I'll be presenting in only 2 minutes. So just give me 2
Sure,
minutes. I'll
it's
be
okay.
presenting.
Before that, then before Ashay represents, Shrecha or Kunal. Yeah.
Sir, is my screen visible?
Yes, it is.
So, API IP address and loopback address. Now, introduction. API IP address means automatic private IP addressing. API IPA is a feature in Windows-based operating system that allows devices on a local network to automatically assign themselves an IP address when a DHCP server is unavailable. This self-assignment occurs within a range of 169.254.0.1 to 169.254.255.254. And for example of API IP address, we can say like if our for smartphone is not getting an IP address from a router it is connected to, then it will self-assign a IP address, which could be looking like a 169.254.0.1, and this IP address is in a range of API IPA address, and the address now your smartphone can easily communicate with other devices such as smart TV, or even without internet access it can access that laptops and smart TV. Now loopback address. The loopback address is a special IP address used to test network communication within a single device. The most common loopback address is 127.0.0.0.0.1, which is often referred to as a local host. We commonly use this loopback address in a very familiar tool, which is Bobsuit. We use that in that to forward the request to our Bobsuit server, and when we forward the request, it loops back to the website so that the website can be accessible by the user. Now API/IP address working. When DHCP request, a DHCP attempts to obtain an IP address from DHCP server upon connecting to a network. And after that, no DHCP response. If DHCP server is unavailable, uh, turned off or misconfigured, the device does not receive an IP address. Now automatic assignment. After a timeout period, the device self-assign an IP address from API/IP range from 169.254.0.1 to 169.254.255.254. Now the subnet mask. The assigned subnet mask is typically .255.255.0.0, allowing communication among multiple devices on same local network. Now local communication. Devices with API/IP addresses can communicate with each other but cannot access external network or the internet. Now conflict resolution. If two devices select the same API/IP address, they detect the conflict and reassign themselves different addresses. Now hence the API/IP enable local connectivity of DHCP server, making it useful for small or home networks. Now loopback address working. When a device is send data to loopback address, it routes the data back to itself, allowing for internal testing and communication. Now API/IP address key features. API/IP address key features include automatic configuration, which API/PA enables devices to automatically assign themselves an IP address when a DHCP server is unavailable. IP address range. IP address ranges from this 169.254.0.1 to 169.254.255.254. Now subnet mask. The default subnet mask for API/IP address is 255.255.0.0, allowing for a large number of devices on same network. Now local communication. Devices with API/IP address can communicate with each other within the same local network, but cannot access the external network or the internet. Conflict detection. If two devices attempt to use the same API/IP, they will detect the conflict and reassign themselves different addresses. No manual configuration required. API/IP eliminates the need of manual IP address configuration, simplifying network setup for small networks. Now fallback mechanism. Acts as a fallback mechanism when DHCP fails, ensuring basic network connectivity. Now limited scope. API/IP is a design for local network use only and is not routable on the internet. Now loopback address key features. Special IP address like the loopback address is primarily .127.0.0.1 in IPv4 and 1 in IPv6. Self-referencing. It routes network traffic back to the same device, allowing for internet communication and testing. Testing and development. Commonly used by developers to test application and services without needing a physical network connection. Isolation from external network. Traffic sent to loopback address does not leave the device, ensuring security and preventing external access. Now, no configuration required after that. The automatically configured on all devices, requiring no manual setup for basic network operation. After that, we comes to network troubleshooting. Used for troubleshooting network issue as it helps verify if network services are functionally correct. Now, standardized behavior. The loopback address behaves consistently across different operating system and network configurations. Now, performance. Provide fast communication since it bypass any physical network interface. Now, API/IP address advantages. It simplifies the network setup by automatically assigning IP address without manual intervention. It enables devices to communicate within a local device network even without a DHCP server. It provides a reliable fallback for basic connectivity when DHCP fails. Now next is the loopback address advantages. Loopback advantages are facilities easy testing of network application without needing a physical network. Ensure security by keeping traffic internal and preventing external access, and automatically available on all devices, requires no setup for basic functionality. Thank you.
Okay. Thank you, Kunal. Just
Thank
a couple of points. So avoid saying now. Okay. So you are saying now for every point and every slide. Okay. avoid saying now.
Okay, sir.
And another thing, too many key features. Okay, just keep as many key features as you can explain if somebody asks. Okay, that
Okay.
you can give examples that somebody asks. Now, for 8 is too much to keep a track, and for you also to explain and
Yeah.
understand and all.
Right, sir.
Right? Yeah. So try to keep it less so that if anyone asks, अगर किसी ने पूछ लिया कभी, so you should be able to
Answer
explain.
that.
And 8,
Yeah.
yeah. And one more thing. Yeah. So the example of the
API, IPA or loopback.
so loopback address example was good. Although API address was not right? You said smartphone and connects to the internet and
Yeah.
all. So
Yeah.
API addresses cannot connect to the internet. They are internal. So a phone would not get that IP address. And even if it gets, it's problematic. So the total, in general, what I wanted to say was, so loopback address is something where your laptop is the requester and the sender. Okay?
Yes, sir.
Yeah, it's for all, no issues. So loopback address is something used for कि जैसे for example Facebook, इस केस में क्या हो रहा है कि एक रिक्वेस्ट आपके लैपटॉप से किसी सर्वर पे जाती है, बट व्हेन यू डू अ लोकल होस्ट, व्हेन यू डू द लूपबैक एड्रेस, आप ही खुद को मैसेज भेज रहे हो, ऐसा हो जाता है. ओके, देन a pipa address is generally a problematic address. ठीक है, if you find it anywhere in your network, it means that something is wrong. ठीक है, and you should get rid of it and you should troubleshoot. ठीक है, that
Right, sir.
pipa, yeah, the reason why I hope everyone is paying attention. Okay, this is not just for Kunal, this is for everyone. So the reason why I said case mein assignments make an assignment on this is because these are special addresses, and for, like I said, for example, a PIPA is a problematic address. Okay, it should not exist in a network, and the reason it would get assigned is कि उसको DHCP नहीं मिला. अगर DHCP नहीं मिला तो it won't connect to the internet और लोकल में ही बात करेगा. But the problem with this is कि वो भी अगर किसी डिवाइस के पास पीपा एड्रेस होगा तो ही कम्युनिकेशन होगा. ऐसा नहीं है कि लोकल में भी किसी इट गोज फ्रॉम एनी टू एनी. दैट डज नॉट हैपन, एंड इन थियोरी इट डज मेक सेंस कि जाएगा, बट प्रैक्टिकलिटी में दैट डजंट हैपन. सो इफ एवर यू फाइंड इन योर नेटवर्क a paper address, you immediately know that something is wrong, and you need to find out what is wrong and fix it. Okay, so that is a
Right, sir.
paper address and loopback address.
Okay. Thank you, sir.
Just want, yeah, thanks Kunal. Yeah, I wanted to conclude all these for these two topics based on all the uh, PPTs. Shreja, you're the only one remaining. Please go ahead.
Yes, sir. So is my screen visible?
Yeah.
Just a minute, sir.
Sorry, did you say anything?
So is this visible?
Yeah. Go ahead, start.
Yeah. So our topic is to understanding API-PA and loopback address. So let's start with an introduction. So what is API-PA address? API-PA address is known as an automatic private IP addressing, a networking functionality that enables a computer to automatically assign themselves an IP address when they cannot obtain this information from the DHCP server. Instead of failing to connect, the device automatically assign itself an IP from a reserved range. API-PA address has a reserved range between 169.254.0.1 to 169.254.255.254, and this range are used when device is unable to get an IP address from a DHCP server. It can be used as a backup of DHCP because when DHCP stops working, then API-PA has the ability to assign IP to a networking host, and it will also uses an ARP, that is address resolution protocol, to confirm the address is not currently in use. Um, how API-PA works? The device first attempt to get an IP address from a DHCP server when set to an automatic configuration. Then if there is no response from a DHCP server, then the device assign itself an automatic private IP address. Then device that uses an API-PA can communicate with each other locally within the same network segment. Then API-PA continues to periodically check for an DHCP server, and once one is found, then it will use the proper DHCP assigned IP address. Then API-PA address has certain advantages or limitations also. The advantages are automatic configuration. API-PA doesn't require a manual intervention or a manual configuration. It's simplifying the setup process. Then it prevents IP conflict. That means API-PA checks to ensure that the IP address is assigned is not already in use. Then other one is simple network management. API-PA is ideal for all small networks like home or small offices network because it requires a minimal setup, and the limitations of API-PA addressing are local communications only. The devices with API-PA address can only communicate with the other devices on the same local network. They can't access the internet or other networks. Uh, Second one is not suitable for large network. API-PA is better suited for small, unmanaged networks, or not large or a complex network. Then third one is a temporary solution. API-PA is generally a fallback method, not a long-term solution for a proper network configuration. Then the loopback address. Loopback address is a special IP address used for testing or communicating with the local machine. It allows a device to communicate with itself for testing and diagnostic. It enables the internet testing and development without using external network resources. It is used to test the network cards, drivers, and the software without a physical network connection. They also allows a IT professional to test an IP software without worrying about the hardware or driver issues. Then loopback address IPv4 range are 127.0.0.0/8, or IPv6 range is 0.0 something has shown. How loopback address works. Uh, the loopback address is associated with a virtual network interface, not a physical hardware. Internal packet handling. Data to the loopback address is processed internally by the device operating system without leaving the machine. And developers and system administrator often use the loopback address for testing network services or configurations locally. Then the advantages of loopback address is first one is a safe testing environment because it's entirely internal. using the loopback address ensures that no external factors interfere with the test. Second is independent of physical network. The loopback address can be used even if the device is disconnected from a network, making it great for isolated testing. Then third one is security. The services running on the loopback address are inaccessible from external networks, protecting them from unauthorized access. Then another is resource efficiency. The traffic never leaves the device, so there is no external bandwidth uses or latency. So the conclusion are API-PA allows a local communication when DHCP is unavailable, and the loopback address is a key tool for a local testing or diagnostic. Or both the features are important for maintaining the network functionality and the security in various contexts. Thank you, sir.
Thank you. Okay, so this images of the workings. Okay, these are good.
Thank you, sir.
Yeah. So like I said, make sure that for others also, make sure that it's not all theory, that there are some images that you can explain and show. Okay. That's important. It gives you a better understanding. And even if, like I said, if you go wrong or if you make a mistake or sometimes you can, miss something, the images speak for itself. It's fine. But in theory, this is very, what is it, noticeable or something like that. In an image, people generally focus on it and self understand. So even if you make a mistake, it doesn't matter much. Okay. Thank you, everyone. Please send your PPTs on mail. Okay. Just a minute. Okay. So Digvijay, first time, Shrecha, Momita, Kunal, Ashay. Ashay is still pending, right?
Yes, sir. So can I present now?
Ashay. It's okay. You present it next time with Prathamesh. It's
Okay, sir.
10:30 already. Yeah. 1, 2, 3. Although you do have assignment, right?
Yes, sir.
Prathamesh, Ashay. Then I'll assume your submission date is today only.
Yes, sir.
Okay. Yeah. The screen visible?
Yes, sir.
Okay. So last time we went through the IP addresses and how we check the network portion, host portion, how we calculate number of hosts, and in general things about subnetting and a network. Okay, that was very in general stuff, foundational. Okay, then we saw the class full and then network address, broadcast address, private and public IP address. Okay, now delivery and forwarding of IP packets. Okay, so the network layer supervises the handling of packets by the underlying physical networks. This handling is called as delivery of packets. This topic is not so much of a what to say um, academic purpose because it branches down to many things, to routing and protocols used and everything, but this is a general idea of what would happen in all those protocols and standards. Okay, so this is the basic principle that everyone uses and they modify accordingly to transfer, as in to deliver and forward the IP packets. Okay, once again. So the network layer supervises the handling of packets by the underlying physical networks. This handling is called as delivery of packets. So network layer focuses on the two layers below it, data link layer and physical layers, to manage the transfer of packets from one point to another, from A to B. Okay, there are two different methods of delivery. One is direct and indirect. Message delivery in the same network is direct. Message delivery in different networks is indirect. Okay, so when internet is included and different networks are present, it would make it indirect. Okay, so for your your home network.
Sir,
Yeah, I'm just saying.
so I didn't
Yeah,
present the PPT yet.
where I asked multiple times, is your PPT ready, done?
Yes, sir.
Okay, you present it later with next time with Asha and Prathamesh. Okay, so
Okay, sir.
three of you will present it next Saturday.
Okay, sir.
Right. Yeah. So home network is considered to be direct network, and anything on the internet, like the communication that you and I would have, will be indirect. Okay. So in generally, when communication is in a local network, okay, communication in local network, a switch is included, and in indirect over the internet, a router is included in the network. So how it will look is basically there will be a switch. Okay, this is a switch is represented by these two arrows. Most common representation, there can be others, but basic understanding के लिए switch is this. So for here there will be my laptop. Okay, there will be my smartphone, there will be my parents smartphone, and so on and everything. Okay, this is connected to the switch, and all of these devices are directly connected to the internet, okay, via Wi-Fi and all. In indirect, so there is devices, okay, there is a switch for the internal communication, and then there is a router for the internet. Okay, so this portion becomes local, and including this one, okay, including this one, including the router, this is the router. If a router is included in this network, then it becomes indirect. Okay, it becomes what? It becomes this type of IP forwarding and all, because message delivery in different networks. Okay, different networks are included. So if the communication is to happen from in the local network, you need switches. Communication between different networks, you need router. Okay, router is needed for communication between two different networks. Switch is used for communication within a network, or let's say local network. Okay, and based on that, like I said, based on that, this direct indirect messaging, based on that, delivery and forwarding of IP packets. So this principle is used differently by other protocols and standards. Next, forwarding means to place the packet in its route to its destination. Since the internet today is made up of combination of links, forwarding means to deliver the packet to the next hop. Okay, what is meant by this? Forwarding is literally as mail forward, WhatsApp पे message forward जैसे होता है वैसे ही. That is what forwarding is. Only in this scenario, internet today is made up of combination of links. Forwarding means to deliver the packet to the next hop. Like I said, इसमें क्या है? इंटरनेट पे क्या होगा? डिफरेंट नेटवर्क्स होंगे, ठीक है? डिफरेंट नेटवर्क्स के लिए क्या लगेगा? राउटर. So there is internet, okay, and internet is made up of different networks. So this is a PC1, PC1, PC2. For local communication, they use a switch, okay, and to communicate with the internet or other networks, they use a router. So this is network 1, okay, network 1. Similarly, there will be network 2, okay, there will be network 3, there will be network 4, and all of these will have a router for communication. Why? Because these are different networks, okay, so all of them will have a router. And since the internet is made up of different networks, it will have different routers, and it's a combination of links, right? So these are nothing but links. This is a link, this is a link, this is a link, this is a link. And forwarding means to deliver the packet to the next hop. So forwarding means from router 1 to router 2 is a hop, okay, and this, when I send a package from R1 to R2, it is forwarding of IP packet. Clear? Okay. Next. Forwarding based on destination address. So there are types of forwarding, you can say. One is next hop, one is network specific method, host specific method, and default method. Okay. There is also something called as based on label. Okay, but that would be an assignment. Okay. So the next hop method. One technique to reduce the contents of a routing table. The routing table holds only the addresses of the next hop instead of information about the complete route. Okay, this is the next hop method of forwarding the IP packets. Okay. So what's our next hop method of forwarding IP packets? Okay, like I said, there is one network, one PC, sorry, two PCs, local communication via switch. There is a router. This is connected to another router who has a switch, who may be having another switch, and there may be 4 devices in total. Or let's say there is just one. Okay. So now the routing table holds only the addresses of the next hop instead of information about the complete route. ठीक है, ये router है to, just a minute. Okay, we're good. Okay, so a router, this is a router 1, router 2. A router has something called as routing table. What is this table? This table is nothing but has addresses of the networks, okay, of the next network. So for example, I am staying in Pune, okay, it has a Pune routing table. What this table has, key from FC Road, you can go to let's say Baner, okay, this is a place. From Baner you can go to Okay, so this is route 1, this is route 2, route 3, but FC say you can also go to RTO office. Okay, so this is route. So routing table has a note of routes, key from where you can go to where. Okay, your source and your destination. So what routes will have? Similarly, in networking, route 1 will have key from network 1, you can go to network 5. Okay, so you can go from IP address 192.168.1.0 to 203.116.0.0. But you can also grow from N5 to N2. There is no route if there is no mention of route of N5 to N1. That means ये सिर्फ one way है, ठीक है? ये जो है ना, this is one way, ठीक है? उल्टा आना allowed नहीं है. It is only one way. Second is not allowed. Okay, routing table should have both the addresses. सिर्फ एक नहीं. अगर N1 to N5 है, so there should be a mention of N5 to N1. Only that means then कि the communication is bidirectional. जा भी सकता है, आ भी सकता है. अगर नहीं है, तो that means it cannot. From N1 you can go to N5. From network 1 you can go to network 5, but you cannot come back. ठीक है? Maybe from N5 you can go to N2 and N2 can come back to N1. तो अगर तुम्हें N1 से N5 जाना है, so you can go directly. But if you want to come back, you have to go from N5 to N2 to N1, from N5 to N2, and from N2 to N1. Okay, so routing table has table of routes. ठीक है, कौन से रास्ते लेने हैं, roads to be taken. Okay, now let's see the example. So we have, I'll just draw it out here. Okay, okay, two PCs. So we have PC A. Then we have this, ये जो है ना यहाँ पे, that is a switch. Okay, used for local communication. Okay. Why is it not changing? It's weird. ठीक. Okay. Something seems to be wrong. Okay. Is my screen still visible?
Yes, sir.
Why am I not able to come to this tab? Okay. Finally. Yeah. So this was PC. अच्छा ठीक है. यहाँ तक किसी को कोई डाउट है ये routes और route tables and what it means? या फिर जिसको समझ में नहीं आया कि ये switch और different networks का? अगर ऐसा physically तुमको दिखा हो ना तो what's going on? ठीक है, तो switch ऐसा कुछ दिखता है. ठीक है, this is a switch. इसमें अब कितने कनेक्ट कर सकते हो? 1 2 3 4 कनेक्ट कर सकते हो. इसमें you can connect 8. ठीक है, this is how network switch looks and this is how the router looks. तुम्हारे घर पे भी तो होगा वाईफाई राउटर, ऐसे ही दिखता है. ठीक है, उसमें भी switches होंगे ऐसे. Okay, you might connect for something and those will be connected to the internet. ठीक है. Okay, I'm assuming everybody understood since nobody said anything. तो वो जो switch मैंने दिखाया था अभी वो connected है and उसको एक और PC connected है. ठीक है, this is for local communication, but I want to connect to another network or internet, another network or internet. Okay, so then this is router 1. Okay, then I have another switch, I have another router, another switch. Okay, again this has one PC, this has two, this has PC, this has PCB. Okay, I want to send a message from A to B. For example, I say ping host B. Okay, now what should happen? The message should go from A to B. But for that, what I need to know, I need to know the route. What is the route? What is the address? Okay, where is that address? Where is that route? That route is in route table in R1 and R2. Okay, but the method that we are using is next hop method. The routing tables hold only the address of the next hop instead of the complete route. इसका मतलब अगर यहाँ पे एक और राउटर होता, ठीक है, if there is another router over here, okay, there is another connection, another switch, or maybe there is another router over here. Okay, in the next hop method, R1 only knows about R2. Okay, R2 will know about R1 and R3 but not about R4. R3 will know about R2 and R4 but not about R1. Okay, it will know only the neighboring or the next hop routers. Okay, because we are using the next hop method. Only the address of the next hop instead of information about the complete route. Okay, so R2 will know about R1 and R3. R1 will know about R2 only. ठीक है, ये क्लियर है? Okay, ठीक है, so let's see. A में देखो, destination host B and route R1 R2 to host B. ठीक है, this is the host information. ठीक है, ये router वाली नहीं है, router वाला R1 है. उसमें देखो, it has only said host B, destination and route R2. That is the only thing that it has or contains. So R1 के टेबल में क्या है? Sorry, R1 के टेबल में, let me do this. R1 के टेबल में next hop information है. He knows that the destination and next hop. So destination is B and next hop is R2. R2 के लिए क्या होगा? Destination तो change होता रहेगा based on the message you said. But since it is a table, it will have A and उसका next hop होगा R1 because ऐसे उल्टा भेजना है अपने को, यहाँ से यहाँ भेजना है. Okay, it is going from here to here in that case, or otherwise it is destination B and R2 because we are sending, sorry, R2 will have R3. ठीक है, we are sending it to the other side, ये side पे भेज रहे हैं. That's why. Okay, so only next hop. For R1 it will only be R2, but for R2 it will be R1 and R3 दोनों होगा उसके पास. Okay, so that's what it is. And R2 will have host B. Again, route is host B. ठीक है, इसमें route है R2 host B, इसमें है host B. So why R2? Because next hop में इसके लिए this R2 is coming. ठीक है, इसमें host B. In the sense, it will first go to R2 and then to host B. First, I have to pick R2, then host B. अब मैं R2 में आ चुका हूँ. So the only thing remaining is the host B, destination B and host B. R3 will still remain क्योंकि यहाँ पे R3 नहीं है, but in this example R3 आगे है. Okay. Then oh sorry, I showed you the wrong. Second, yeah, this routing tables based on next hop. That's what I was saying. D. My bad. So we were correct. So R1, R2, R3. Okay. R1 will have destination as host B and R2. R2 will have destination A, R1, destination B, R2, and this will have only R2. ठीक है, इसमें let's say C वाला computer है. Okay. So focus on the B part, routing tables based on next hop. This second A. Okay, this is next hop R1, next hop R2, and then you come to the destination. Okay, the first one is based on route. Okay. Okay. The first table is based on route. You can ignore it for now, but otherwise it's the same. You take R1, R2 and to the host. This is a little misleading because ये A वाला host का table है, not of a router. Focus on the router 1 and router 2 tables. Okay. Next, network specific method, reducing the routing table and simplifying the searching process. So the routing table has only one entry that defines the address of the destination network itself. The host specific routing table for host S. Please note this is a host specific routing table. Okay. So destination is A. Every of this PC is connected to router 1. That is why no matter तुम destination कौन सा डालो, next hop is always R1. Okay. This is the host specific routing table. But network specific method में network specific routing table कैसे दिखेगा? You have N2 which is a switch and its next hop which is R1. ठीक है, तो इस केस में कैसे होगा? Network specific में you have a PC, you have a PC, ठीक है? You have a switch. This is a switch. You have a router. Then again you have a switch, and this has 4 PCs. ठीक है? Now instead of routing table में instead of putting in सबका या फिर next hop का, what I do, I put this network. ठीक है? So what I do network which is N2. This network, and where do I get this N2 from? This R1. So my destination is N2, next hop is R1. ठीक है? This is routing table by network specific method. अगर if it was next hop method, the routing table would have destination. This is A, B, C, T. It would have destination A, router 1, destination B, router 2. ठीक है? Like this. ये जो यहाँ पे A, R1, R2, R3. So instead of having 4 entries, it has only one entry which is N2, और उसका hop कहाँ से जा रहा है? उसका route कहाँ से जा रहा है? Through R1. Okay. So that is next hop method हो गया, network specific method हो गया. Now host specific method. The destination host address is given in the routing table inverse of network specific method when an administrator wants to have more control. ठीक है? So we have 3 networks, we have host and 3 routers, and host B can be reached by R3. Okay, it can also be reached by R1 and R2. So उसका routing का कैसा होगा कि you will have R2 with an entry to R1 and then N3 through, this should be R2, huh? This is wrong. This should be R2. So N3 to from R2. Okay. Next. Default method, instead of listing all networks in the entire internet, host can just have one entry called the default. So default R2, rest of the internet. For internet, it is default destination. Next hop is R2. For network 2, it is N2 and route is R1. Okay. So there was forwarding based on destination address we just saw. Okay. This is forwarding based on destination address. उसमें चार types है. Next hop, network specific method, host specific method, default method, and there is forwarding based on label. Okay. So your assignment for next week is to find out about forwarding based on label. If you get a diagram, a picture, that would be great. Okay. For 4 methods, I have used 1, 2, 3, 4 and 5 max. Okay. So I expect 5, what do you say? 5 slides for this as well. Okay. Excluding the introduction and conclusion part. So forwarding based on label should be 5 slides. Keep it minimal, and I am only concerned with the working. Key features, advantage, ye wo, not required, not needed. The only thing is working. Okay, so 2 main points that for the assignment. The priority is how it works. Okay, it should be that should be the only content. Okay, it should be 5 or less, or you can take more. There's no problem. I mean, if it is not fitting and all, you can't do anything. I'm just giving you an example ki on an average 5 should be there. Okay, and diagrams and pictures should be there. So based on it कि तुम एक स्लाइड पे एक डायग्राम डालोगे, दूसरे पे कंटेंट लिखोगे, वैसे. ठीक है. So that's your assignment for next week. We have already gone through IPv4. ठीक है. You can check the recordings of last lecture. I think I have not given you access. I'll give it today. No issues. So we went through this IPv4 protocol and what is IPv4 addresses and what it actually works, how it works, how we do the calculation in the last lecture. We'll go through the theory part now. Okay. Okay. So Internet Protocol version is a widely used protocol that provides the foundation for internet communication. It is 4th version of the internet, hence the version 4, hence the IPv4. And it has been used since 1983. It helps for routing and delivering packets out across networks or internet. Okay. Numerical identifiers assigned to devices of the network. Structure of IP consists of 2 main components, the network address and host address. Again, we have gone through it, and I've also told you how we identify the network part and the host part. Okay, this is just the theory that we are going through. The network address identifies the network to which a device belongs, while the host address distinguishes individual devices within that network. This line is the most important, and I hope you guys have understood it. Okay. Subnets created by using a net mask. Net mask is nothing but the subnet mask that I told you. Division between the network and host portion of the address. This defines the size of the network and host segments. Size of the network मतलब जो हमने अभी देखा आज /16 say you get 65,000 PCs, right? You get 65,000 devices. So the size of the network is determined by the net mask, which is also known as subnet mask. IPv4 addresses are 32-bit long. अगेन 8 बिट का एक सेक्शन और ऑक्टेट, द सेक्शन इज कॉल्ड एन ऑक्टेट, ऐसे 4 ऑक्टेट्स. So 8 bits plus 8 bits plus 8 plus 8 gives you 32, typically expressed as a series of 4 decimal numbers such as एक example दिया हुआ है, and it ranges from 0 to 255, allowing for 4.3 billion unique addresses. ओके, असाइनमेंट 3 IPv4 वर्सेस IPv6. इसके लिए पीपीटी बनाने की जरूरत नहीं है, and you don't have to present it either. You can send me this in a Word document over mail. ठीक है. Assignment 2 should be a PPT and you will present it. Assignment 3 IPv4 versus IPv6, no need to present it, but you can send me a Word doc. Assignment 2 forwarding based on label PPT, individual, no group. Assignment 3 IPv4 versus IPv6, individual, Word doc, PDF, JPG, whatever you want to give. JPG इंटरनेट से उठा के मत देना, ठीक है? ये अगर तुमने खुद क्रिएट हुआ तो again no exceptions or delays in assignment 3. ठीक है, assignment 2 के लिए you can. And another message that I want to say is Prathamesh Ramesh, I'm just noting it down as a way of कि meeting notes जैसे होता है वैसे, ठीक है? I'm just noting down the today's highlights. So Prathamesh, Ashay, and Kuber to present PPT on a paper and loopback address next week. Okay. ठीक है. Yeah, so like I said, this forwarding an IP packets and this is the basic principle that has been used in other protocols and standards. So going deeper into this makes no sense. Hence the assignment on forwarding based on label. We should have the knowledge of it, but there's no need to go in more deeper or concern us with the intricacies of the protocol, okay, or standard, whatever you want to call it. Next, okay, ARP will do it next time. Okay, let's go through the theory at least. Okay, let's see what address ARP is. ARP stands for Address Resolution Protocol. It is a network protocol used to determine the MAC address from any IP address. Okay. This is what ARP is. If somebody asks ARP, so it is a method to identify or calculate MAC address from any IP address. Okay. It is a network protocol used to determine the MAC address address from any IP address. In other words, ARP is used to mapping the IP address into MAC addresses. When one device wants to communicate with the other device in a LAN, the ARP is used. Okay. Okay. ARP is a local area network protocol and not a layer 3 or internet protocol or between networks wala protocol. Okay, it is not a WAN protocol, it is a LAN protocol, local area network protocol. Okay, ARP is a network layer protocol. This is very important protocol to the IP suite, although it has developed in the early 80s. It was defined in RFC 826 in 1982. ARP is implemented with important technologies like IPv4, X.25 frame relay and ATM. So all this ये जो हम करते हैं IPv4, IPv6 प्रोटोकॉल फॉरवर्डिंग ये सब कुछ कहाँ पे डिफाइंड होता है RFC एंड एक पर्टिकुलर नंबर में. ठीक है. So if you go see, this is where the definition is. ठीक है. This document is followed by everyone all over the world, every company, every person, every employee, everyone. This is what they refer to. This is the definition. ठीक है. So RFC, for example, I don't know ऐसी कोई document है क्या, but let's see. Oh, there is. So RFC 1908 में क्या है? Coexistence between version 1 and version 2 of the Internet Standard Network Framework. So RFC और कोई number होगा. What it shows you? It shows you the definition or the legal document, legal definition of something on the internet. Internet के जो standards, rules, protocols, technologies, concepts जो हम use करते हैं, उसका definition कहाँ पे बताया जाता है? RFC और उस particular number of that RFC. ठीक है. So if ever you want to check anything or verify, you can go on Google, put RFC and the number. अगर मिलता नहीं है तो डायरेक्ट गूगल डालो, वो RFC नंबर आपको खुद दे देगा. ठीक है. So ARP का definition, legal definition that is accepted all over the world by everyone in the world, कहाँ पे है? RFC 826 में. If you want to go and check. Similarly यहाँ पे जो है ये forwarding based on label, इसका भी एक RFC होगा. ये डिफॉल्ट मेथड वाला जो फॉरवर्डिंग है उसका भी एक RFC होगा. IPv4 का भी एक RFC होगा. ठीक है, कि कैसे डिफाइन होता है, क्या डिफाइन होता है. लेट मी सी इफ आई हैव मेंशन्ड इट एनीवेयर. लेट्स सी. सो इट्स RFC 791 जिसमें IPv4 ये है इंटरनेट प्रोटोकॉल. ठीक है. Prepared by Defense Advanced Research Projects Agency Office, Virginia, US. ठीक है. तो आर्मी टेक्नोलॉजी फॉर एग्जांपल. Okay, army technology का another example is dark web. Okay, it is an invention by the US Navy. ठीक है. उनके जो labs थे, they invented the dark web. So like that, उसका definition वगैरह सब you'll get it here. See, Information Institutes, California, so and so. इसमें they define कि कैसे होता है, operation क्या होता है. Okay, on September 1981, what happened? ठीक है. Then this was the overview. Okay, let's go. Let's see if we have 1983. We don't have 1983. ठीक है. और कहाँ? Let's see if we have the definitions. ठीक है. इंटरनेट हेडर्स भी है. ठीक है. हेडर्स कैसे डिफाइन होते हैं, क्या होते हैं. Okay, this is an example of internet datagram header, so on. So you can explore it on your own. Okay. Sorry, back to the theory part. Yeah, we are done. Okay. Thank you. That would be all. अगर doubt हो तो पूछ लो. We can continue. Otherwise, we are good.
सर असाइनमेंट 3 कब तक सबमिट करना और 2 कब तक?
Both next week. Like I said, assignment 3, this is basically just answering a question. IPv4 IPv6 is just a question. Won't take you more than probably minutes. So both next week. Okay, that's it for today. Thank you.
Thank you, sir.
Thank you, sir.